Hello everyone, I am Alexandru Macsim.
Hello, my name is Jamal Mohammed.
Hi, my name is Ulfat.
We are computer engineering students at Politecnico di Torino, and today we are going to present to you our computer architecture project that we did this year.
Okay, it was a Blackjack game designed using the Verilog HDL language, and we implemented it in a Zinc board.
So now we're going to show you the game itself. We will now demonstrate it.
First of all, I will try to talk a little bit about the board that we are using. It is a Digiland Zibo Zinc board, and it is an FPGA, which means that we can program it as we want in order to make her do anything. As we can see, it has already been connected to the screen through a VGA port, and it's also connected to the USB, which is both it is both using the power for the board, and and we also program it through the USB cable. As you can see, the board has a series of buttons and switches that we are using as inputs for our game. For example, we are using the first button as a start button, so we can make the game begin. Then we have a button that allows us to increase the bet for each hand that we are playing. We have a button for passing, and the button for asking another card from the dealer. Finally, we are also using one of the switches in order to have a hard reset of the game. So in case it freezes or anything, we can just restart everything through one of the switches.
Okay, now I'm going to demonstrate how the game is played. So if you see, now I am pressing the button start. Okay, now the game starts. As you see, I pressed the start button, which is button 3. And then before starting, we have to set the betting amount, and when the game starts, automatically the program will give me my balance as a 50 units, and then I have to decide how much I want to bet by using button 0 as seen from the screen. So it's 5. If I want to increase it, I will again press button 0. Again, I will bet like 15 for this game. Okay, to start. Okay. Now, as you see, I have 19 and the dealer have 4. I will accept this 19 because it is near to 21. So I will pass to the dealer by pressing button 2. I lost. You see, the sum is 20 for the dealer and 19 for me. And when I lose this screen, the color red color means that I lost. So let's start again another game. Button 3. I will bet all 25 units that I have. Okay, start. 16.6. Then I will hit 21. No, 23. So I lost again, and over. I finished all my balance. So to have a new balance, I have to restart the game again.
Now we are going to explain you how the game logic actually works. So game logic is implemented using Verilog VHDL, and here we can see schematics of it. So after elaboration, everything, we will automatically create the schematics of it, and now we try to explain a little bit about the game logic and how it works, actually, how it flows. Now we move to. Okay, let's move now to the logic part. Okay, so here we have a main logic part of the game, and here we can see every button is connected to it, and it has several outputs, which is going to VGA. Actually, the game part is sending like dealers and players cards data to the VGA, and the game state also, and balance. So here we are using clock divider to divide the clock, because the board itself has very fast clock, and we are dividing it to VGA and the game differently, because the game clock should be very slow respect to VGA. So now let's zoom into game logic part. Okay, as you can see here, so okay, let's move here. Okay, game logic consists of mainly from the control unit and state unit. Okay, so here we have state unit. So depending on the pressed buttons, it defines state of the game. So and the state monitor sends the signals to control unit. Control unit, of course, controls every model in the game. Here we have also separate modules for dealer and player, just to control the player and dealer hands, and check if they are passed or not. Okay, let's zoom out. Okay, here we can see interconnections. Actually, it becomes very complex, but it is not so complex as it is. So here we can see a separate model for balance, of course. So it counts player balance and manipulates it. So as you have seen in the game demonstration, when you have bets, I mean, everything is controlled by this balance module. And okay, so that's all with the game logic part.
And go.
All cert.
No, I cannot. It should be like 25.
Okay. We can do
I
that.
hope 10. Come on, 10.
No.
Yeah! 21! Blackjack, finally.
Okay, that's all we wanted to say about the project. I hope you enjoyed this video.
And this is all. We want to thank our professors for the support they give us, and this is all.
Yeah, the project was so interesting. We learned a lot about how to design hardware and how to write a program in Verilog, and we really learned a lot. It's so interesting, and thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Bye.
Bye.